two important vocabulary words when you're describing the key features of functions, graphed functions anyway, are domain and range. What domain means is what x values exist as part of the function. Range is what y values exist. So all you have to do is look at the graph. If you have the graph, it's pretty straightforward. You look at the graph and say, where do I see x values and where do I see y values? And then we have to get into how you write it, which is another bit of stuff. So let's just look at the graph first and figure out where the x values exist. We're going to talk about domain. And really, I guess this should be, there are some things that go without saying here. One is that when you see lines going off the edge of a graph, you should usually interpret those as being arrows, even if it doesn't say arrows. So what this is saying is the function goes down and to the left forever and down and to the right forever. So you can imagine, does -6 exist as an x value? Well, yeah, sure. It's not shown, but we can assume the function exists down here, and it's going to keep on going forever. So I can play that game, -7, -8, -9, forever. I could say this thing exists all the way out to -infinity in the x direction. And likewise, all the way out to +infinity in the y direction. There's only one exception. This annoying little hole in the graph right here. It's called a removable discontinuity, right there. That is like a speed bump that we've got to say, well, yes, the x values exist everywhere except right here. Okay, so this is the exception. So the way we're going to say this idea in math is we're going to start at -infinity, and we're going to go all the way through all those negative numbers, all the way until we get to -2. We stop at -2. We don't quite get to -2. That's what these open parentheses mean. The open parentheses mean you don't quite get that far. And then we hop over the discontinuity and start again on the other side of -2. So this is like, you can read that as meaning something like -1.99999, right? It's almost -2, but not quite. So we're starting at -2, and now we're going all the way out to infinity. There's no more holes. So that's how I would describe the domain of a function that has a hole in it. The range is the y values. Okay, so look at this picture. Think about what sorts of y values we have. Clearly, these are all good. These are all y values that exist. And it goes down to -infinity, right? You can see these going down forever. So I could say, again, -infinity is as negative as you can get. And we'll never actually reach -infinity, so I use the open parentheses since I can't touch that value. And then I go more positive until what happens? You might say, well, until you hit that hole right there. You can't actually have -4. And if we're only looking at this side of the picture, like if we ignore all that stuff, then I would say you're absolutely right. We can't touch -4. But the other side of this graph exists, and you can touch -4 right over there. So there is a place in this function where y equals -4. So I wouldn't worry about stopping at -4. I would keep on going until I get to this point right here. That's the true end of the road. You can't get any higher in y values than the vertex of this parabola. So I'm going to say this goes from -infinity up to -3, and it cannot go any higher. There's no y values up here, right? They just don't exist. So now how do I say this? If I put a parentheses here, it's going to be wrong, because in this case, I actually can touch that point, y equals -3. It does exist. So to say that idea, I'm going to use a square bracket. The square bracket says, hey, this number right here, it really is part of the graph. You have to include it.